Okay. Page 502, section 9.6. It's called, not called that. It's called solving right triangles. You might think that's what you've been doing, but it isn't. You've been finding one particular thing that the problem or story problem asks you to find. Today, what you're going to do is find all the missing pieces in a right triangle. And in order to solve a right triangle, they have to give you 3 of the 6 pieces. What I mean is, every triangle's got 3 and 3 angles. They're going to ask you to find, they're going to give you 3 of those things, and they're going to ask you to find the other 3. The best way to handle that is to draw a picture of it, and then list the 3 things that you don't know, so you know what you're after. Okay? So we're just going to dig right in. Start with the, let's see. Determine which of the 2 acute angles are close. I don't know how to do that. Example 2 says, I do need to teach you that. Yeah, I do. Okay. In order to find a missing angle, sometimes you're going to have to be able to use the inverse functions of trig on your calculators. So we will need to practice this for just a minute. What we're going to do in a second or two is we're going to do stuff like this. Find angle x so that the cosine of it is, let's say, 0.75. Let's find the sine of x. That's equal to find the angle whose sine. That's what we're going to be doing here. Is finding that angle. That's 0.32. And maybe the tangent of an angle that is 3.21. Okay. But I don't expect you to know how to do that yet right now. So I want you to follow my reasoning here. And I'm going to lead you to how to do this in just a minute. I'll give you a reason for it. Just do this with me. Just trust me. If you have, forget these for a minute. If you have x plus 7 equals 13, how do you solve for x? And that's what everybody believes, right? Got to subtract 7? Why subtract? Why not divide? Why not multiply? Why subtract? Because you do the opposite of what? Okay. In math, when you talk about opposite things, I guess, yeah, they're called inverses. Addition and subtraction are inverses of each other, right? They don't. One does not always give something smaller. Like, for example, 3 minus negative 7 actually gets bigger. 3 minus negative 7 is 10. Yeah? But addition and subtraction are inverse operations. What's the inverse of multiplication? Division. What's the inverse of squaring? Square rooting. What is the inverse of signing? Cosine. No. Nice try. You don't know what the inverse of sine is, apparently, because nobody's speaking up. But you all seem to know about the algebraic inverses. Addition and subtraction, multiplication, division, using exponents versus roots. But here's the deal, folks. I'm going to go through a couple more of these. What would you do if I had 1/3 x equals 8? Times it by 3, because here it's 1 divided by 3. It's the same thing as saying x over 3, right? So x is being divided by 3. What do you do to get rid of it? You do the inverse of dividing, which is multiply by that 3. Yeah?
Yeah.
What if you have the square root of x equals 7? What do you do to get at x? You square, because square rooting and squaring are inverses. They undo each other, leaving you with just x, right?
Yes.
What if I had x to the 3rd equals 18? How would you find the value of x? No, not square root. Cube root, because cube rooting and cubing are inverses, right? You do it to both sides, leaves you with x on that side. We got a similar situation here, and it asks me to find out the value of x. I've got to somehow get rid of that cosine. And if you remember, I did tell you this right at the very beginning. These are transcendental functions. This is not cosine times x. Cosine by itself, this phrase right here, is worthless without something to cosine. They're together as a function, and you can't just get rid of cosine by division because it's not cosine times x. It isn't. It's the cosine of x equals 0.75. So how are we going to undo cosine?
Isn't like cosine and then it has a -1 at the...
Yes, and up here we said addition and subtraction were inverses, and they're different words. Addition is the inverse of subtraction. Multiplication is the inverse of division. Squaring is the square root, the inverse of square rooting. Cube rooting is the inverse of cubing. The inverse of cosigning is actually called inverse cosine. And it's written like this. If I were to take this side and inverse cosine it, it looks like that. Now, I know that you know that if you have x to the negative 1, that's the same thing as 1 over x. That is not what's going on here, not even a little bit. And I'm sorry about the notation. But when we say inverse cosine, we mean to undo the cosine. We mean to find the angle whose cosine is x. And in algebra, what you do to one side, you have to do to the other. So what's really happening, inverse cosine, cosine, they undo each other just like cubing a square root, a cube, or squaring a square root. They undo each other. Multiplying by 3 undoes each other. Subtracting 7 undoes it. Inverse cosining undoes cosine and leaves you with just x. But what you do to one side, as you learned over there, what you do to one side, you have to do to the other. And so we go inverse cosine. Take our calculators and do inverse cosine. And by the way, that application is found just above the cosine key, and you have to hit the second function first. So notice on here on your keys, cosine and tangent, and right above them in some color or another, they've got each one of those with a negative 1 on it, right? You see what I'm saying?
Yes.
So what I want to do, because I've already solved for x on this side, what I got to do is inverse cosine 75. So I go second, and the cosine function, it types down a parenthesis, puts 0.75 in there. And you get, I'm not in the right mode. Hang on a moment. I was just teaching calculus, so hang on.
41.4.
Yeah. 41.4 what? Degrees. These are degrees. It's an angle that we found. Because you always cosine an angle. If I peel that cosine off of there, I'm left with the angle. And the angle in this case is 44.4 degrees about. By the way, these are always going to turn out irrational. If you want to let your reader of the problem know, which is me or anybody else who wants to look at it, if you want to know that this is an approximation, just put a dot over the equal sign. That's a quick way to say approximately equal to.
Isn't it 41?
What's that?
Isn't it 41?
Is it?
Yeah.
41? Oh, is it? Yeah, that's what I get for talking while I'm writing. Sorry, you're right. It's 41.4. You're right. It is. Now, everybody, based on all that huge monster discussion, find x whose sine is 0.32. See if you can find the angle whose, when you sine it, gives you 0.32. What do we get?
18.7.
Okay, so x equals 18.7. And the way we did it, it's approximately equal to that. The way we did it is we peeled the sine off by inverse signing. That left us with x, but we had to inverse sign this side. So now everybody find the angle that goes with that tangent. What is it?
72.7.
Good. So this is how you recover the degree measure of an angle. If you don't know what that angle is, you have to inverse whatever, both sides. And it will tell you the angle so that when you sine that angle, you get 0.32 or whatever. Do you see how I undo it? Okay. All right. You're going to need that today because solving sometimes in a triangle requires you to find the angles in this way. Okay. So that was example 2 or something like it. Now let's take example 3 and actually solve a triangle. Example 3 says, on page 503 says, solve the right triangle, round decimal answers to the nearest tenth. So to solve the triangle means find all of its missing parts, the length or size of all of the missing things. So here we have a 3, a 2, and a C, and it's a right triangle. Now what is, do they have letters on these? What is this?
B.
B? This is A and this is C, right?
Yes.
And it's kind of important that you have something to reference like that because your next thing I would recommend you do is list the things you don't know. I don't know little c. I'd like to find that. I'd like to find angle B, and I'd like to find angle A. Those are the 3 pieces missing. The 3 that they gave us is the fact that this is right. This side over here is 3. This side over here is 2. The things that are missing are this third side and these 2 acute angles. Do you agree?
Yes.
All right. So now, how could we go about finding little c? There you go, I heard it. Pythagorean theorem. So what we would write is, because these are the legs, we would write 3 squared plus 2 squared equals c squared. That's 9 plus 4 equals c squared. And so the square root of 13 equals c. And they want us to round to the nearest tenth. So we would actually have to square root that. Rounded to the nearest tenth is 3.6. Anybody do that on the calculator?
Yes.
You're working with me here? Okay. So now we know what C is. I would highly recommend that you don't use C unless you absolutely must, because this is an approximation which can throw off your incoming results. You should use that 2 and that 3 to find anything you need as much as possible. You don't want to use this. And if you do use it, I would use it in its exact form, square root of 13, so that you're not approximating anything. Do you understand my words?
Yes.
Yeah? Okay. So now I need to find angle B and angle C. Let's go after angle B first. I need to find this angle, and I want to use the 2 and the 3 to do it. What trig function would tie them together? There's only one that will apply to this. Tangent. And the reason we decide that is because the 2 and the 3 are opposite and adjacent. And opposite and adjacent is the TOA part of SOHCAHTOA. That's tangent. Do you understand the choice? So if I'm going after angle B, I want to say that the tangent of B, because that's the thing I don't know, so just leave it a variable, is opposite over adjacent. How do I find B? Inverse tangent fraction, just like we just did. B will be the inverse tangent of 2 divided by 3. And since, well, that's only 1.5. You could use 1.5. No, it isn't. It's 0.6 repeated. Sorry, that's screwed up. So don't use 0.6 repeated. Use 2 divided by 3. That way it'll be exact. So we go second and tangent of 2 divided by 3, close the parenthesis, and we get 33.7 rounded to the nearest tenth. Do you agree?
Yes.
Now, the cool thing is that even though this is an approximation, it's not really that approximated in here. To find A, I really only need to subtract this from 90 because these two got to add up to 90. I don't need to use a trig function on A to find it, but I could, but I don't need to because I have 2 of the angles known. This is what's left over. And since I've already used up 90 there, and we've already discussed the fact that this and this are complementary, I'm just going to subtract. I'm going to say 90 minus answer, and I get 56.3. And this is what you box up for your answer. See you guys. Good luck. Okay. Anybody not follow this, all this right here? Everybody understand why we chose tangent?
Yeah.
You have to choose the right one, the correct one. Okay? I don't want to be in that picture. Okay. Let's try another one. Example 4 says, solve the right triangle, round decimal and 6 minutes 10. Exactly the same thing we did before. So here we go. Another triangle to draw. This one's called HI, GHI. Looks like this. So we don't have to stick with A, B, and C. We have, is this G?
Yes.
And this is H?
Yep.
Okay. GHI, and that means that this is little I, this is little h, and this is little g, and I think they gave us some of them. On the picture, they said that the hypotenuse was 13 and angle H was 25. So I'm just going to write 13 here. And this is 25 degrees. And this is the right angle. So the 3 things they gave us were this side, this hypotenuse, that angle, and that angle. We got to go find the other 3 things, and they are little g, little h, and big G. And big G is the easiest one of all. You all see that that's a pretty easy calculation? What is it? 5? 65. Yeah. 65 degrees. That one's easy. And because that turned out to be exact like the 25, you can use that 65 degrees. We didn't come up with it, but you can use it if you want. Which one do you want to go after next? G or H? Doesn't matter. G. Okay, let's go after G next. Do you want to use 25 or 65? It doesn't matter.
65.
65. Okay, and with respect to this 65-degree angle, how could I use that and the 13 that I know and to find that G? What's the relationship between those three? Opposite over hypotenuse, which is sine. So we choose the sine of the angle, and this time it's not a b like it was over there, it's actually a number. The sine of 65 is equal to G over 13. Would you all buy that? Now you need to understand too, we could have used cosine, but it would have been cosine of 25, cosine of 25, because that would have been adjacent over hypotenuse. But I asked which one you wanted to use, and I heard 65 first, so that's what I'm going to go with. So I'm choosing sine to find G. What?
After that, would you multiply by 13?
Yep. Cross multiply. 13 sine of 65 equals G. And G is already solved for in the cross multiplying, so all you have to do is calculate that. 13 sine of 65. $11.8 to the nearest tenth. Is that right?
Yes.
That's what you're getting? Now, we could use Pythagorean theorem to find this, although I kind of hesitate to because this is an approximation. I really don't want to use it in a calculation. You could. If you use the one that's in your calculator, chances are you won't have any trouble at all. But I'd rather dodge this, using this if I can, because I don't like to use approximations in any other subsequent calculations. So let's pretend I didn't want to use Pythagorean theorem here, but I still wanted to find h. Which angle do you want to use? 25 or 65? Because it doesn't matter. 25? Okay, I heard 25 more than others. So if we go with 25, then how does the 25 angle relate to the h and the unapproximated 13? I'm not going to use g in any of my calculations either. Opposite over hypotenuse using the 25 would be sine again, but it would be of 25 this time. Sine of 25 equals h over 13, cross multiply, calculate. $5.5? Okay. There's that one. You kind of see what you're up against?
Yeah.
You got to find all the missing parts, and you have Pythagorean theorem available to you, all three trig functions. Try to use pieces that you know for sure. That aren't approximations. Try not to use the approximations unless you absolutely must. And if you absolutely must, because there's nothing else, then use the approximation in here, not the one you rounded to the nearest tenth. Okay? You want to avoid approximation errors as much as possible. One more thing, and that's example 5. It says solving a real-life problem. Here's what we got. Your school is building a rate stage. This is kind of weird. A rate stage. The stage will be 30 feet long from the front to the back, that part that you get to stand on and act, okay? With a total rise of 2 feet. That's huge. You want the rake, which is the angle of elevation, to be 5 degrees or less for safety. Is the rake stage within your desired range? So you raise the stage up so that you're leaning, so that instead of being flat, you're actually leaning towards the audience. It shows them a little bit more. But you're a slant if you're on the stage. Okay, so the stage that they have drawn in the picture, for those of you watching this video and can't see it, looks like this. It's a side view. We've got the flat, and then we're going to rake the stage up like this, and this over here at the very back side is going to be 2 feet. And this is supposed to be 30 feet. And we want to know if this is 5 degrees or less. That's the question. So I'm not going to put 5 degrees there. We're going to compare when we're done. I'm going to put theta there. Well, I can call it angle A if you want. So what ties this angle that we wish to know with this opposite side that we have in a hypotenuse?
Sine.
Sine, once again, sine of A is equal to 2 over 30. How do we find A?
Well, this is over hypotenuse, which is 2.
You don't cross multiply anything. We're trying to get at that A, which means we got to peel that sine off. Inverse sine of 2 over 30. We want to inverse sine both sides. We inverse sine this side, that wipes that out. Inverse sine this side, that's the calculation we've got to make because we're trying to isolate that angle A. Do you understand what I'm saying to you? If you're looking for an angle, you're going to use inverse. So this will be the inverse sine of 2 divided by 30 And we did, yeah, 3.8 degrees. So, looks like we can rake it that much. 3.8 degrees is what A turns out to be, and it has to be less than 5, so we're okay. So it's okay to raise the back of the stage 2 feet, and we'll still be within the safety zone. Is that okay? Follow that? Okay. And then you see we are at the exercise. So you get to be solving triangles, bunch of them. Yay! All right, you ready? The trick is to make the right decision on sine, cosine, or tangent based on the angle that you either know or are trying to find and the sides and how they're oriented. You can use that SOHCAHTOA a lot. Anyway, here are the exercise numbers. Do the best you can. I'll be here to help you. 1 through 21 odd. 22, 23, 27, and 29. That's not a killer assignment, except every problem requires you to find 3 things, so it is kind of killer. It's 15 questions. And you may have to find as many as 3 things for each one, so there you go. Let me know if I can help.